Let us look at proposition number 9 of book 1 of works of Archimedes, specifically on the sphere and cylinders. The proposition says, if in the circular base of an isosceles cone, a chord is placed and from its extremities, straight lines be drawn to the apex of the cone, the triangle so formed will be less than the portion of the surfaces of the cone intercepted between the lines drawn to the apex. So here what the proposition is saying is, we have drawn a triangle in a cone, then the area of this triangle will be less than the surface area of the balance of the cone which has been cut off by the triangle. So let's proceed. Let ABC be the circular base of a cone. So let me mark C with the apex as O. Draw a chord AB in the circle and join AB and OA and OB. Bisect the arc ACB at C. So the arc has been cut at C such that the arc AC is equal to arc BC, and join AC, BC and OC. Triangle OAC plus triangle OBC is greater than the triangle OAB. Height is same for all these three triangles, and here AC plus BC is going to be greater than AB. So that means these triangles would be having this property. Let area D be such that triangle OAC plus triangle OBC is equal to triangle OAB plus D. So let me bring in D. We have seen that triangle OAC plus triangle OBC is greater than triangle OAB. So by whatever quantity that it is greater, that quantity is represented as D. Now, there are two cases here. Either D is greater than the segments of the circle AEC. Let me mark E and F. So the area of D is greater than the circular segment area AEC plus CFB, or it is less. So since there are two cases, let's take it one by one. So let D be greater than the segments of the circle AEC plus CFB. Now, surface of OAEC, the section of the cone, it's a surface area plus the segment circular base of that section of the cone, that is AEC, have the same extremities. Since they have same extremities, we can say surface of OAEC plus segment of the circle AEC is greater than the triangle OAC. This is part of one of the assumptions. Now, surface of OCFB plus the segment, circular segment CFB have the same extremities with triangle OBC. So which means again surface of OCFB plus segment of the circle CFB is greater than the triangle OBC. Surface OAECFB. So what are we doing here? We are adding up this statement and this statement. So surface OCFB plus OAEC if we take both these surfaces, then we end up with surface of OAECFB plus segment of the circle AEC plus segment of the circle CFB is greater than the triangle OAC plus triangle OBC. D is greater than the sum of the segments of the circle AEC and CFB. That is our case 1 condition. So, which means surface of OAECFB plus D is much greater than triangle OAC plus OBC. Look at this, surface of this plus segment of the circle AEC plus segment of the circle CFB. But D is greater than the sum of these two, segment of the circle AEC and CFB. So since it is greater, that means the left-hand side of this inequality will become much greater than the right-hand side. If we substitute the sum of the segment of the circle AEC and the segment of the circle CFB with D. So now this triangle OAC plus triangle OBC is greater than OAB, which we have reworked as triangle OAC plus triangle OBC is equal to triangle OAB plus D. So we can replace this triangle OAC plus triangle OBC with triangle OAB plus D. So the surface of OAE CFB plus D is greater than triangle OAB plus D. And if we subtract D from both the sides, we are left with surface of OAE CFB is greater than the triangle OAB. So we have proved the first case. Now let's look at the second case, where D is less than the segments of the circle AEC plus CFB. So we bisect arc AC and arc BC, then bisect their halves and so on till segments of the circle which are together less than D. Now while marking the points E and F, I had purposely marked it as a point of bisection. So that we have done the bisection once. Now let's bisect it once more at G, H, K, L, and let's join OE and OF. Now let us say that the segments of the circle AGE, EHC, it's better if I draw these lines as well. Okay, so now AGE, EHC, CKF and FLB. If we sum them up, then together they will be less than D. Surface OAGE, the section of the cone, its surface area, plus the area of the circular segment AG is greater than OAE, this triangle. Why? Because the extremities are same and the triangle is inside this cone. Now, similarly, surface OEHC plus segment of the circle EHC is greater than the triangle OEC. Again, extremities are same and the triangle is inside the section of the cone. Surface AGHC plus segments of the circle AGE plus EHC is greater than OAE triangle plus triangle OEC. So basically we have added up these two statements. Now triangle OAC is less than the triangle OAE plus triangle OEC. Why? Because again their extremities are same, but the triangle OAC is inside these two triangles. So we can say triangle OAC is less than the sum of these two triangles. So surface OAGEHC, this section of the cone, plus the base of that section of the cone, that is AGE plus EHC, is greater than the triangle OAC. Now triangle OBC is less than the triangle OBF plus OFC. Again, because the extremities are same and the triangle OBC is inside these two triangles. Now, which means surface OBC KFL plus segments of the circle BLF plus CKF is greater than triangle OBC. So when we add up these two, what do we get? We get the surface OAGEHC KFLB, this entire surface area of the section of the cone, plus the segments of the cone, base of the cone, that is AGE plus EHC plus CKF plus FLB is greater than the triangle OAC plus the triangle OBC. Now, surface OAGE HCKFLB plus segments of the circle AGE plus EHC plus CKF plus FLB is greater than triangle OAB plus B. Why? Because remember, triangle OAC plus triangle OBC is equal to triangle OAB plus B. The sum of the segments of the circle AGE, EHC, CKF and FLB is less than D. So since it is less than D, if we subtract this segment, sum of these segments from this statement, the left hand side becomes less because we have removed these bases, and this also becomes less. But since this is less than D, surface OAGEHCKFLB is greater than triangle OAB plus some magnitude. That magnitude will not have an impact on this relationship if we remove it. So surface OAGEHCKFLB is greater than triangle OAB. Now try to understand this carefully here. This sum is less than D. So if I remove this from here and D from here, what happens? The left hand side becomes lesser to a smaller degree than the right hand side. So the inequality still remains the same. So that is proposition number 9 of book 1 of works of Archimedes, specifically on the spheres and cylinders. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.